hello students. Today we are going to discuss chapter 1 from the class 9 syllabus of mathematics, that is number system. So before studying or getting into this topic of number system, let us first try to recall all the numbers that we have studied in our previous classes. So the first type of numbers were natural numbers. I hope you remember what is a natural number. So natural number are nothing but counting numbers, those numbers that we can count. Okay, starting from 1. Those numbers that are countable are known as natural numbers. So let us just write a short definition. Counting numbers are called natural numbers. Example, it will always start from 1, 1, 2, 3, and it goes on, right? So next type of numbers are whole numbers. Now what are whole numbers? Natural numbers along with 0. If in the group of natural numbers we just started with 0, then that whole group is known as what? That whole collection of numbers are known as whole numbers. So whole numbers, you can write natural numbers or counting numbers along with 0 are called whole numbers. For example, it will start from 0, 1, 2, 3, and it goes on, right? So next are integers. Now all of us studied about negative numbers, positive numbers, and 0, right? So in whole numbers and natural numbers there are no negative numbers, right? But if we consider the negative numbers along with the whole numbers, that means the negative numbers and the positive numbers along with 0, then that whole set of numbers are known as integers. So integers, they are a collection of positive numbers and negative numbers along with 0. For example, -4, -3, 0, 1, 2. So these are all integers. So now I hope it is clear about natural numbers, whole numbers, and integers. So now we will get into the next type of numbers, that is rational number. Now what is a rational number? Any number that can be represented in a form of p by q. Now what is p by q? P by q, you can say it is a general form of a fractional form, right? So numbers that can be represented in the form of p by q. One more thing we have to consider, where p and q are integers. Here p and q both need to be integers and q cannot be 0. Okay, for example, you can say -3 because it can be written as -3 by 1, right? 4, 3 by 2, Okay, but we can also take a decimal number 1.5. If I remove the decimal, it will be what, 15 by 10, right? But if I say, suppose just for example, I'm showing you 4 by 0, then this becomes, this cannot be defined, right? Infinite, it cannot be defined. So that's why the denominator in a rational number q cannot be 0. Remember that. So this is not a rational number, right? So etc. So I hope it is clear. Those numbers that can be represented in fractional form where both the numerator and denominator p and q are integers and the denominator can never be 0 are known as rational numbers. Okay. Now irrational numbers. Irrational numbers are those numbers that cannot be represented in the form of p by q. Okay, I will show you with example. So numbers that cannot be represented in the form of p by q are called irrational numbers. For example, if I give you a simple, all of us are familiar with pi, right? What is the value of pi? 22 by 7 or 3.14. Right? Now you tell me whether pi is a rational number or irrational number. It is a irrational number. Why? Because this 3.14 we have rounded off and we have written the approximate value. But actually it is 3.141 and it goes on. That means this is a non-terminating decimal. Non-terminating means the decimal that does not have any ending, and non-recurring decimal. We will discuss about decimals also. Similarly, if I take root 2, what is the value of root 2? 1.414 and it goes on. Right? Similarly, this is also a non-terminating decimal. That means if I remove the decimal, I can never write in fractional form, na? Because it will go on. So how we can write in fractional form? It is not possible to write these numbers in fractional form. That means we cannot write it in the form of p by q. That's why these numbers are called irrational numbers. Similarly, root 3. These are all irrational numbers. Okay. I hope it is clear till here. So now let us try to understand about decimals, okay, order number or the decimal numbers. So if I give you one example, 1.5, right? 15 by 10. So this is a non, sorry, this is a terminating decimal because it has an ending, na? Because after 5 it is not going on, right? It has an ending, so it is a terminating decimal. This kind of decimals are called terminating decimals. So you tell me terminating decimal can be represented in the form of p by q, it can be represented in fractional form. So terminating decimal are what? They are always rational numbers. Right? If I give you another type of decimal, suppose 1.3145, like that it is going on. Now this type of decimal has no ending, so they are called non-terminating decimal. Now you tell me, can it be represented in fractional form? No, right? But we have to consider one more thing. We have to see whether the digits are repeating or not. Okay, now non-terminating decimal are also of two types: non-terminating recurring decimal and non-recurring decimal. Suppose 1.314, it is this way. It is non-terminating, but here the digits are repeating. Can you see? This is non-terminating recurring decimal. Recurring means repetition of digits. The digits are repeating. That's why it is known as recurring. And non-recurring means what? The digits are not repeating. There is no repetition of digits. Okay. Now, somehow we have to solve this type of sums. Somehow we are able to convert the non-terminating recurring decimal into rational number. Suppose 314 is repeating, we will put a bar on it. Okay. After that, it is possible to convert this type of decimals into rational numbers. Okay. But we will never be able to convert this type of decimal numbers into rational numbers, into p by q form. That's why the non-terminating and non-recurring decimals are always irrational numbers. If it is non-terminating, you always check the digits are repeating or not. If the digits are not repeating, then it is surely an irrational number. If it is non-recurring, then it is surely an irrational number. But if the digits are repeating, then we can convert it into a rational number. So it is known as rational number. If it is non-terminating but recurring, the digits are repeating, then it is a rational number. Clear? If it is terminating decimal, it is surely a rational number. If it is non-terminating and recurring, then it is a rational number. If it is non-terminating and non-recurring, then it is a irrational number. Clear? Now next is real number and imaginary number. Now we have discussed about rational numbers, irrational numbers, right? Now if we consider both the rational numbers and irrational numbers and we put it in a collection, that collection will be known as real numbers. What are real numbers? Real number is a collection of rational numbers and irrational numbers. That means -3 is a rational number, it is a real number. √2 is a irrational number, it is an irrational number, but it is a real number. Okay, so it goes on, right? Now what about the numbers that does not fall into this category? What about the numbers that are neither rational nor irrational? So let me give you an example. If I take root over -1, okay, now root over -1 does not fall in this category of rational and irrational numbers. Now that is an imaginary number. Now first let us try to understand what is imaginary number. The square of the numbers that are negative are called imaginary numbers. Suppose we have always heard that the square of a number is always positive, right? But if I give you one example of -1, okay, if I do the square of -1, what I will get? Root over will cancel with this square and I will get -1. Similarly, -2, if I do the square, then I will get -2, right? Root over minus 3, if I do the square, then I will get minus 3. So we are getting the squares as negative. Now these numbers like root over minus 1, root over minus 2, root over minus 3, these are imaginary numbers. They are imaginary numbers. Okay. Now one more thing. Suppose root over 2. This root over 2, I can write it as a product of root 2 and minus 1, right? Now this, just to simplify it, this root over minus 1 has a value. It has a symbol which is known as I. This I represents minus 1. I, what is the name of this I? It is known as iota. Okay. Now this root over 2 and minus 1, this I, if I represent, if it represents iota, then I can write root over 2i. So these are imaginary numbers. Okay. So this is iota, and this root over 2 and minus 1. Minus 1 if I consider as iota, then I can write root over 2i. Okay. So this is a little bit complex topic. It is not required for general mathematics. Just you remember real numbers and imaginary numbers, just for your information what are imaginary numbers, that is required. Okay.